Environmental Construction Program, Designer's BMP Training. Stormwater runoff can pick up harmful pollutants and deposit them into drainage systems, streams, and the ocean. Construction activities may be sources of potential pollutants such as sediment, concrete waste, vehicle and equipment fluids, material and chemical spills, lavatory waste, and trash. Stormwater is typically not treated after reaching the storm drainage system, which means pollutants could have the potential to reach our streams and oceans. On-site pollutants can also contaminate the soil and groundwater. Help keep our waters clean by implementing the BMPs discussed in this training. Construction projects also have the potential to impact our waterways after construction is completed. Increased imperviousness, if not properly managed, could result in more runoff and an increased potential for pollutants to enter nearby storm drains and waterways. One way to address this increased risk is to incorporate post-construction best management practices, or BMPs, into a project design. This will be discussed later in this video. We'll start with a reference to DOT Airport's Construction Site Runoff Control Program webpage. The webpage houses many helpful resources for project teams. Important resources to note for designers would be the Post-Construction Best Management Practice Manual, or PBMP Manual. SOP, Environmental Requirements for Construction, or SOP. VOC, Quick Reference Guides, or VOC QRGs, as well as a list of other helpful links to templates and forms for designers and tenant improvement projects. We will refer to this webpage as the DOT Airport's website throughout this video. AIR-EE uses VOC, an online platform for the design review process. All project representatives who intend to upload submittals or respond to design review comments during the design review process must register for a VOC account. You will be directed to establish your VOC account at the beginning of the process. Additional representatives may request a VOC account by reaching out to AIR-EE. The project workflow will comprise of a process that will guide the designer through each step of the construction design review. After each submittal step, the AIR-EE design reviewer will review the submitted documents and provide comments. The designer will be notified when comments are available and can then revisit the workflow to upload revised submittals and respond to comments. VOC will retain an ongoing record of open comments from the designer and design reviewer for reference. Required submittals include drafts for the AIR-EE review, final versions for AIR-EE records, and records confirming submittals to other authorities. VOC will serve as both a review and record-keeping platform for these project documents. As mentioned previously, there are various quick reference guides, or QRGs, available on the DOT Airport's website to aid in using the VOC platform. We recommend referencing these QRGs if you are unfamiliar with using VOC for the design review process. We are also available to assist if you have any questions with the platform or process. There are three classifications for construction projects: exempt projects, projects disturbing less than 1 acre, and projects disturbing 1 acre or greater. Each type of project varies in the information needed during the design review process. We will discuss a bit about each type. Exempt projects. Examples of projects that are deemed exempt from the full construction review process include, but are not limited to, the following. At the start of the design review process, the designer will provide project information. AIR-EE will then determine if the project is classified as exempt or non-exempt. If the project is classified as exempt, a notification will be sent to the project representative and the review process will be complete. Projects that are approved as exempt from further AIR-EE review shall nevertheless implement appropriate BMPs to prevent construction activities from contaminating stormwater, groundwater, and soil. There might also be additional documents needed from the project, such as the inclusion of the DOT airport's specifications. AIR-EE will instruct the project at the time of the exemption if additional information is needed through the VOC platform. As mentioned previously, a comprehensive resource is available on the DOT Airport's website titled SOP Environmental Requirements for Construction, or SOP. This SOP provides additional information of the process, documents, and permits mentioned in the following sections. The disturbed area calculation determines if the project is classified as less than 1 acre or 1 acre or greater. DOT Airports follows the Department of Health, or DOH, definition of disturbance of land, or disturbed area. The penetration, turning, or moving of soil, or resurfacing of pavement with exposure of the base course, or the exposure of bare soil or ground surface, including the land surface exposed by construction roads, base yards, staging areas, demolition, headquarters, and parking areas. It does not include grass or weed cutting, bush or tree trimming, or felling that leaves soil or ground intact. It includes grubbing in its normal meaning of the use of equipment to knock down and push vegetation out of the way, typically uprooting vegetation and disturbing the ground surface. The following construction activities are often missed in the disturbed area calculation: construction work that exposes base course and construction support areas such as staging areas, equipment storage, stockpile storage areas, construction office trailers, vehicle parking areas, etc. Note that if a project is part of a larger common plan of development, the land disturbance associated with the entire development shall be considered. The required submittals are dependent on this project classification. Please calculate the project disturbed area carefully and feel free to reach out to AIR-EE if you have any questions during this step. Once the project classification is determined, the designer will fill out the associated documents. Here, we'll discuss common applicable items needed for construction. This table can be found in the SOP. The columns on the right of the table indicate documents needed for each type of project. Projects both less than 1 acre and 1 acre or greater will submit construction plan sets and DOTA project specifications or tenant improvement project scope of work, preferably starting at 60% design and ending with 100% design. This will give AIR-EE the opportunity to make comments early in the design process. Project teams can reach out to AIR-EE and set up a meeting at any point during the design review process if the project team has questions regarding DOT Airport's environmental requirements. A Stormwater Pollution Prevention Plan, SWIP, or Site-Specific Best Management Practices, SSBMP plan, will be required depending on the project classification. Templates for both are available on the DOT Airport's website. A National Pollutant Discharge Elimination System, or NPDES construction permit, Notice of Intent, or NOI, application will need to be submitted to DOH for projects with a total land disturbance of 1 acre or greater. The designer must draft the NOIC using the DOH Environmental Health Administration e-permitting portal and send to AIR-EE for review prior to submitting to DOH. Note that any consultation with DOH for information or clarification must include AIR-EE. DOT Airport's construction, connection, discharge, and surface runoff permit is required for all projects. The Contaminated Soil and Groundwater Review Form, Phase 2 ESA Subsurface Evaluation Sampling and Analysis Plan and Phase 2 ESA Subsurface Evaluation Report are required for all projects. If a project has received an exemption from AIR-EE, the Phase 2 ESA Subsurface Evaluation Sampling and Analysis Plan and Phase 2 ESA Subsurface Evaluation Report are not required. The bottom of the table lists common permits and documents that may be needed depending on the project scope. All these items are described in more detail in the SOP. There may be additional requirements beyond this list depending on the project scope, including projects involved with USTs or ASTs. AIR-EE may request additional permits or documents prior to construction, and projects may be required to provide additional information to AIR-EE, such as those generating hazardous waste or managing contaminated media. Please refer to the DOT Airports SOP for additional information. Contaminated media. The project will first submit the DOT Airports Contaminated Soil and Groundwater Review Form during the project information step. Depending on the site information gathered by AIR-EE, a pre-construction subsurface evaluation sampling and analysis plan and associated subsurface evaluation report may be required. For small or relatively simple construction projects that are unlikely to have the presence of a contaminant release, AIR-EE may determine that the project can proceed through design and construction without further consideration of or investigation for the presence of contamination. In such cases, the project must comply with the DOT Airports Programmatic Environmental Hazard Evaluation and Environmental Hazard Management Plan, or DOTA EHE EHMP. This document can be found linked on both the DOT Airports website and within the DOT Airports SOP. This document is considered to be in effect for all construction projects that do not have one of the two applicable Construction Environmental Hazard Management Plan, or CEHMP, types that we will mention later. Both the DOTA EHE EHMP and a CEHMP are intended primarily to describe the measures that will be implemented to protect site workers, prevent further release of contaminants to the environment, and appropriately handle contaminated soil, sediment, or groundwater. In the case where a project site had no previous documented contaminant release, but contamination above applicable DOH environmental action levels was encountered during the pre-construction site investigation, a CEHMP will likely need to be established for the project. This CEHMP is usually drafted by a qualified environmental professional on the design team and must be prepared in accordance with the DOH Hazard Evaluation and Emergency Response, or DOH HERE Office's latest CEHMP guidance. A link to the DOH guidance can be found in the SOP. CEHMPs are always intended to be implemented in conjunction with the DOT Airports Programmatic EHE EHMP. Designers should be aware that in some cases, the presence of contamination will require that remedial measures be implemented or installed during or upon completion of construction. The technical elements of these measures would be established in a remedial action plan, which must be approved by AIR-EE and DOH. The remedial action plan may be prepared by a qualified environmental professional on the design team or by a third party and shall be incorporated into the design and specifications by the designer. The most common types of remedial action plans describe remedial measures such as the excavation and disposal of contaminated soil, storage tank and piping removal, and/or hazardous material abatement. Other remedial measures are designed to put long-term protections in place. These are most commonly impervious caps, vegetated covers, or vapor barriers over contaminated areas, and designed to prevent post-construction exposure and/or releases of contaminants to the environment. Design submittal considerations. The next few slides include important considerations for designers to keep in mind as they prepare the documents for the design review process. A BMP map or maps shall be submitted with site-specific BMPs. Utilizing the project's Erosion and Sediment Control Plan, ESCP, sheets may suffice but must include all project areas that require construction BMPs. All project activity limits must be clearly defined, including staging areas. Stormwater flow directions must be shown either with spot elevations or flow arrows. Project grading sheets can be utilized to satisfy this requirement if effective. Receiving drainage features, including inlets, catch basins, streams, etc., must be shown with environmental identification numbers or EIDs, if available. Stabilized construction entrances and exits must be shown, including locations and details. Perimeter BMPs are required along all perimeters where stormwater runoff from disturbed areas has the potential to flow off-site. Post-construction runoff conditions. It's important to consider additional runoff resulting from new impervious areas. If an increase in off-site runoff is anticipated after incorporating PBMPs into the design, a drainage study must be conducted to assess the capacity of the downstream drainage system. If the downstream drainage system is not sized to handle the additional runoff, redesign of the site or the system may be needed. Final stabilization. All disturbed slopes must be adequately stabilized, such as with vegetation. Site conditions should be taken into consideration for final stabilization measures. If site conditions are infeasible for vegetation, other final stabilization measures should be considered, such as riprap or turf reinforcement mats. Consider design approaches for PBMPs that contain sloped areas such as vegetated swales. Components for velocity dissipation or flow control, such as check dams or level spreaders, may be included depending on site conditions. Post-construction best management practices, commonly referred to as PBMPs, are permanent features constructed to treat potential pollutants. Development often results in an increase in impervious area and more stormwater runoff, and therefore a higher chance of pollutants contaminating stormwater, groundwater, and soil. The main goal of incorporating PBMPs is to reduce or eliminate pollutant discharges from the site after construction is completed. Projects will undergo review for PBMPs through the design review process on VOC. The PBMP manual, available on the DOT Airport's website, provides in-depth guidance on all things from applicability, implementation, design criteria, operations and maintenance, and more. PBMP variants. Projects may be eligible for a PBMP variance, which allows the project to forego PBMP installation. An example of a qualifying PBMP variance is if the project is solely to address water quality improvement or preservation, such as shoreline protection, landscaping, PBMP installation retrofit, and permanent erosion control. The designer will fill out the PBMP variance section of the design review process and provide project information for AREE's review and approval. Projects that are not approved for a PBMP variance will need to implement PBMPs. There are three types of PBMPs: low impact development, LID, source control, and treatment control. LID PBMPs and LID waiver. LID PBMPs seek to mimic pre-development hydrologic processes of infiltration, filtration, storage, evaporation, and transpiration to manage stormwater runoff naturalistically in an integrated manner. By implementing LID principles and practices, water can be managed in a way that reduces the impact of built areas and promotes the natural movement of water. LID PBMPs are the preferred and first considered type of PBMP during the project's design review process. The project will be prompted with questions in the LID PBMP infeasibility and waiver section of the workflow to determine if LID PBMPs are feasible. We will go over a few examples of common LID PBMPs in the following slides. A bioswale, sometimes referred to as a bioretention swale or enhanced swale, is a shallow channel with a media layer covered with vegetation, mulch, or other surface material. Runoff filters through a media layer and discharges at the downstream end of the swale. An infiltration trench is a long, narrow, rock-filled depression with no outlet, where stormwater runoff is stored in the void space between the rocks until it infiltrates through the bottom and into the soil matrix. According to state and federal UIC program regulations, an infiltration trench is considered a Class 5 stormwater drainage well if it is deeper than wide. Infiltration trenches that fall under the Class 5 injection well category shall apply for a UIC permit. When new UICs are installed, modified, or abandoned, applications and final reports must be submitted to AREE for review and then once approved to the Department of Health Safe Drinking Water Branch, or DOH SDWB. LID PBMPs are susceptible to clogging from sediment, leaves, and debris that could lead to premature failure. Suitable pretreatment systems such as sedimentation basins, forebays, or manufactured treatment devices such as hydrodynamic separators help maintain the infiltration rate of the device without frequent and intensive maintenance. If LID PBMPs are not feasible, an LID waiver will be granted, but projects may still be required to implement non-LID PBMPs. Source control PBMPs are measures that prevent pollutants from coming into contact with stormwater, groundwater, or soil. Tenants who maintain an NPDES Industrial Stormwater General Permit should review this section to verify all applicable source control PBMPs are included in their industrial SWIP. Maintenance area design involves incorporating design criteria for maintenance and repair activities. Considerations include locating maintenance and repair areas indoors or under cover where possible, and creating impermeable bermed areas to prevent wash waters from entering the drainage system or receiving water. Material storage area design involves incorporating design criteria for material storage activities. Considerations include secondary containment structures, designing outdoor storage areas to be covered, or designing them to preclude stormwater run-on and run-off, and routing downspouts such that runoff will not flow through material storage areas. Treatment control PBMPs are designed to remove pollutants from stormwater runoff prior to discharge. A dry detention basin can provide stormwater runoff control and improve water quality using a shallow, man-made impoundment. This design provides temporary storage of stormwater to allow particles to settle and retain stormwater until it can be released slowly over time. Including flood detention storage can also provide flood control, since dry detention basins do not have a permanent pool and are designed to drain completely between storm events. In order to assure the feature does not pose a safety hazard to aircraft, wildlife deterrence should be considered when designing. An oil water separator, OWS, is primarily designed to remove oil, jet fuel, gasoline, diesel, other water-insoluble hydrocarbons, floatable debris, and settleable solids from stormwater runoff. The two commonly used OWSs are the conventional American Petroleum Institute, or API separator, also known as the baffle type, and the coalescing plate separator. Both use gravity to remove floating and dispersed oil. Manufacturers have developed several proprietary versions of OWSs for stormwater treatment. The pollutant removal performance may vary depending on the type and model of the proprietary OWS selected for the project. Therefore, project proponents need to review the manufacturer's specifications to determine if the OWS will sufficiently remove targeted pollutants. A hydrodynamic separator, or HDS unit, is known as a vortex separator, swirl concentrator, or continuous deflective separator, or CDS unit. HDS units are gravity separators and are essentially wet vaults that use a vortex action to separate coarse sediment and floatables, trash, debris, etc., from stormwater to the surface of the upper chamber using a non-mechanical, non-blocking screen technology. Some models may also remove oil and grease. Facilities that include parking, fueling, maintenance, and washing for vehicles should consider units that have oil storage. The pollutant removal performance may vary depending on the type and model of the proprietary HDS unit selected for the project. Therefore, project proponents need to review the manufacturer's specifications to determine if the HDS unit will sufficiently remove targeted pollutants. PBMP considerations. Various factors shall be considered when selecting a PBMP for a site. It is important to implement PBMPs that consider site condition limitations for the PBMPs to serve their purpose. This can help avoid issues such as flooding, lack of vegetative growth, or disruption to underground utilities. The questions within the VOC workflow will help you identify these potential issues. Another factor to keep in mind is sizing the PBMP appropriately to handle the stormwater runoff from the design storm using the post-construction runoff coefficients. The PBMP manual has sizing guidelines for both volume-based and flow-based designs. The designer must identify the site-specific pollutants of concern based on planned activities, planned site design, land use type, legacy pollutants that may potentially be present on the site, changes in stormwater discharge flow rates, velocities, durations, and volumes resulting from the new development or redevelopment project, sensitivity of receiving waters, and receiving water quality. If the project discharges to a water body included on the DOH 303D list of impaired waters, the pollutants listed as impaired for the water body must be given special consideration. Table 4-1 in the PBMP manual lists the effectiveness of pollutant removal for each type of PBMP. Designers will also need to develop a PBMP O&M plan. For state projects, DOT airports will be responsible for long-term maintenance. For tenant improvement projects, tenants will be responsible. Applicable O&M plans and warranty information will need to be submitted to AIR-EE prior to the closing of the project. Designers should consider the level of maintenance needed for the life of the PBMP. It is recommended that a cost analysis for operation and maintenance for several PBMP device design alternatives is provided to DOT airports or the tenant to aid in selecting the appropriate device. PBMP operations and maintenance O&M fact sheets can be found in the PBMP manual for reference. We hope this training video gives you a good base of knowledge and familiarity with references at your disposal as you complete the design review process. If you have any questions, please reach out to the appropriate AIR-EE personnel or dot.air.environmental@hawaii.gov. Mahalo for completing this training video and helping to keep our waters clean. Malama I kawai.